All right, good evening, everyone. Just wanted to run through one more example of our mixed repeated measures ANOVA design. Again, working with an example that we talked about in class, working with unordered means, but wanted to go through and talk about a way we might go through and explore the interaction we saw in these vignette ratings, and thinking about some of the considerations that we might have within these data. So if you recall, with this example, this is something that we built off our one-way repeated measures ANOVA design, looking at when presented with vignettes about people experiencing different types of trauma or stressful life events, the extent to which participants rated their willingness to maintain friendship with these individuals. Now, in the one-way example, we went through 8 different vignettes. Here, we're going to cut it down. We're just going to restrict it to looking at participants' willingness to rate, their participants' rating of their willingness to maintain friendship in response to people exposed to motor vehicle accidents, combat deployment, sexual assault, or natural disaster. And recall that within this mixed design, what we're doing is based on responses to a previous measure, put these individuals into different classes. We've got a negative group of individuals who generally endorse some more negative beliefs about trauma. People who've been exposed to trauma are dangerous, they're untrustworthy, they're unreliable, they're just trying to get attention, things like that. In the negative class, benevolent class, marked by generally positive beliefs about trauma responders, trauma survivors. And then the interpersonal group being somewhere in between here, is generally saying nice things, but endorsing some reservations about interpersonal contacts with people exposed to serious trauma. I would be unwilling to, or I would be hesitant to develop a relationship with someone exposed to serious trauma. So we've got our 3 different groups. So we've got a 3x4 repeated measures design here, with repeated measures on the last factor. Our 3 levels to our between subjects factor is our classes, negative, benevolent, and interpersonal. Our repeated measure here is ratings of these vignettes. Again, these were counterbalanced, so ratings of vignette for MVA survivor, combat survivor, sexual assault survivor, and then a disaster survivor. So as we go through, we're not going to work through it, sort of the individual screening within this example here, but going through some things that we noted. One, distributions on this rating. Again, 0 to 8 rating. Distributions are pretty skewed. In general, people are reporting higher levels, but of willingness to maintain friendship. If you look at the means, we're close to the top of the scale generally, and so that gives us the only place for our variability to go is in the negative tail. So we've got some negative skew within these data, but reasonably large sample sizes, right? So our cell sizes are reasonably large. So we're less concerned about some of the observed distributions because, again, remember that our assumption is based on the distribution of sample means. We wouldn't expect scores in the population to be normal, but recall that our distribution of sample means starts to become very normal when we start to get reasonably large cell sizes, which we have. So that's going for us. Downside is that looks like we have an unbalanced design, 2-to-1 difference, at least from our benevolent to our negative group. And so some concerns with our unbalanced design, and then also as we're going through and taking a look, and if we go through and take a look, and you can calculate this on your own, some differences if we're looking at F max in terms of our variability within repeated measures within groups doesn't look too bad, although our F max for our largest, the ratio of largest to smallest variances within our negative group, we get an F max of 2.85, 2.9. So it's not something to be terribly concerned about. But getting a Fmax of close to 4 when we're looking at variability across time to about 3.83, and so with the unbalanced design, it's certainly looking like we might have some violations of homogeneity of variance. So that's again something to think about. If we go down through, remember, ignore boxes, ignore multivariate tests. Take a look at the test of sphericity. We're assuming that we violated anyway, so we're not going to be too concerned about that. We're just going to jump right down, use our corrected statistics. And again, as we discussed in class, here we have a clear, reliable effect of our repeated measure, suggesting that collapsing across classes. If we collapse across classes and don't break people into classes, it looks like we have differences somewhere in the pattern of mean values across these repeated measures. So there's something different going on in there. We also go down, if you recall, jump down here, and if we look at our between subjects effects, we also see a reliable effect of class in our between subjects effects. Now, we typically have less interest in our between subjects effect. Remember, this is saying that collapsing across repeated measures, that in general we see differences across these classes in their overall rating of whether or not they're willing to maintain a friendship with survivors of these hypothetical traumas. So within the context of this design, this does start to become interesting because it's suggesting that regardless or irrespective of what vignette we're talking about, there's at least one class reporting friendship ratings that are systematically higher than or lower than at least one other group in here. So this actually becomes kind of interesting within the context of this design. So this is our main effect of our repeated measure. Here's our main effect of our between subjects factor. And then if we go up here, we see that we do have, with our greenhouse geyser correction, a between by within interaction. We've got, looks like that pattern of means across our repeated measures, our friendship ratings are differing in some way by class, right? So basically, this significant interaction is telling us that class membership, whether or not you're a member of the benevolent, the negative, or the interpersonal class, we're seeing that the pattern of means across these different vignettes, how people are rating their willingness to maintain friendship with these hypothetical individuals, is differing in some way by class, right? And so this is very interesting. This is what we're going to go down through and explore. So if we go back down, remember, we're not going to worry about our within subjects contrast because we're going to go through, we don't have ordered means, and so these really aren't going to mean much of anything. Would want to stop and take a look at our Levine's test here. As we talked about before in our initial screening, some concerns that we may have a violation of homogeneity variance. And if we take a look here, we're seeing that at least from our between subjects approach, right? If we were to run a one-way ANOVA across our three classes for ratings in response to the MVA vignette, the combat vignette, the assault vignette, and the disaster vignette, we're seeing evidence of reliable differences in overall variability in friendship ratings across classes here, again suggesting that we've violated one of our assumptions of the overall test. And so good news is that overall effects are going to be fairly robust to this, but as we read in Howell's chapter, and again I would strongly encourage you to work through that chapter, it's very good. Starting to be concerned about the extent to which we can start going through and pulling error terms from our overall omnibus test to start looking at simple effects and specific contrasts and things. So go down through and take a look. Recall that with just the 4 trauma vignettes that we're looking at here, this is going to be our graph of our between by within interaction, suggesting again that somewhere within these pattern means that class membership is impacting the pattern of means across these different vignettes. Have our means here in our graph here. Now eyeballing this, it looks like our interpersonal and our benevolent class are pretty similar, but looks like there's something going on with this group of individuals who's reporting sort of quite negative beliefs about people who have been exposed to trauma, the consequences of trauma, things like people exposed to serious trauma are dangerous, or they're unreliable, or they're violent, things like that. And so seeing some differences here. Now, the thing that we need to think about is how are we going to go through and starting to tease apart some of the simple effects within the context of this interaction. Again, there's just a lot of ways that you can do this, and hopefully some of this is going to be determined based on your a priori hypotheses, what we expect to turn out of these data. If we start going through and looking at all pairwise effects, both between and within, this starts to get really, really high and questionable on sort of the extent we need to go through and start making corrections. And so for the purpose of this example, let's pretend that our example with our one-way ANOVA, where we saw that we did get differences in people's response to different vignettes. Let's pretend that that was a pilot study. Okay, it wasn't, but let's say it was, and that before we even ran this, we had reason to suspect that, in general, people's willingness to maintain a friendship with someone specifically who had been on a deployment or had been exposed to combat trauma, based on these previous data, that people were reporting maybe some hesitations about that relative to what we might call civilian trauma, car accidents, sexual assault, disaster. And so within that context, let's say that we had expected that we would see people rate willingness to maintain friendship with our combat survivor as being less than the combination of our motor vehicle accident, our sexual assault, and our disaster survivor. Okay, and so for our within subjects contrasts, what we're going to propose is to run specific contrasts comparing our combat vignette with the MVA, the sexual assault, and the disaster vignette within each one of these vignettes. And so here what we're going to get is a test for whether or not this is different than the combination of these three within each one of these classes. Okay, so that takes care of our within. Now we could test other things, but that doesn't look like that's going to be a good use of our time. And so because we're saying that we've predicted this on the front end, what we'll do is we'll go through and compare those, let's say, at per comparison error rate. So we'll test each one of those at alpha 0.05. But let's say we weren't sure how these classes would differ from one another across each one of these vignettes. And so we'll say that for the purposes of this example, in addition to our a priori contrasts within each group, what we're going to do is we're going to run a between subjects contrasts across at each one of these time points. Now, if we're looking at this, right, we're eyeballing this and we're like, oh, well, maybe what we want to do is for our between subjects contrast, we want to compare our negative group with a combination of our benevolent and interpersonal. So we can do that, right? But the issue is we kind of just came up with that on our own after we've already taken a look at the data, right? And so from a perspective of post hoc testing, what we've done is just by looking at these data, we've already ran all possible pairwise comparisons across each one of these, right? And so we can't just really say, oh, we're going to do 1, 2, 3, 4 between subjects contrasts, and so we're only going to correct for 4. We kind of already ran through in our mind all of these, and so what we should probably do is try and get some sort of correction that's going to get close to sort of the possible number of comparisons. And so at each time point, right, And let's look at this one because this one will be easy to see. Because we've got 3 different groups, there are 3 possible pairwise contrasts that we can run. We've got 1 versus 2, 1 versus 3, 2 versus 3. So we've got 3 at each time point. That gives us a total of 12 comparisons that we probably just ran in our head, that if we're going to go through, if these are truly post hoc and we didn't have any a priori, we should probably try and get some correction that's getting around that vicinity. Okay, so just like we did in the last example, some options, and these are kind of straw men because you shouldn't use Bonferroni or Dunn-Sidak for exploratory analyses. But if we were to Bonferroni correct for 12 comparisons, we would be testing things at an alpha level of 0.004. Dunn-Sidak actually rounds up and gives us something similar. And then we talked about this modified Tukey. If we go through and we say, okay, well, we're looking to control for 12 tests. If we set R equal to 5, that's going to control for 10 possible pairwise comparisons. Remember, R times R minus 1 over 2, so we've got 5. If we set R to 5, that's 5 times 4 is 20, divided by 2 is 10. R equal 5 controls for 10 comparisons. If we bump it up to 6, that's going to control for 15. That overshoots our mark. Now, depending on how conservative we want to be, we could go that route, but for the purposes of this example, let's set R to 5 and say, okay, what we're going to do is we're going to officially correct for 10 comparisons. In terms of degrees of freedom, again, some options here. Again, for the purposes of being conservative, what we might want to do is go through and control and set our critical value for degrees of freedom associated with the smallest degrees of freedom of any pairwise test. So if we run back up and we take a look here, our degrees of freedom for our smallest tests are going to be our interpersonal, any pairwise comparison between our negative and interpersonal group. So that's 85, 44 plus, minus 2, it's 127. So if we say, all right, we're going to get a little lean on our R, but we're going to be conservative with our degrees of freedom, what this does is it would give us a critical Q of 3.92. And again, if we go through and type in Tukey critical value, Vaster Stats does a nice job. We can go through and say, all right, we're going to set R to 5, degrees of freedom 127, calculate 3.92, right? And so we know, so if we get our critical Q for our corrected post hoc of 3.92, we take that 3.92 divided by square root of 2 to give us a critical T in our roundabout way, and so we're not correcting for exactly, but we're getting something that's close, would be testing all of our contrasts, or at least our exploratory contrasts, against a critical T of 2.77. Okay, if you were to go through and take a look at seeing what that p-value would look like corresponding to these, if we went and so go to our p-value calculator, our graph pad, say 2.77 at 127 degrees of freedom, gives us a p-value of 0.006, right? So again, it's going to be less stringent than either of these, which makes sense because we shouldn't be using these for post hoc tests anyway, but it's still pretty stringent, right? So essentially we would need to get a p-value of less than 0.006, but really what we're going to be doing is testing against our critical tests here for our pairwise comparisons. Now, we're not going to run 10 comparisons or 12 comparisons. What we're going to do is what looks like going to be a most efficient use of our time, is we'll just run between subjects contrast, comparing our negative against the combination of our benevolent and interpersonal. But remember, sort of we kind of, if we're being responsible, we should probably go through and correct. And if we're sort of holding our feet to the fire, basically what we've done is we've already compared all possible pairwise comparisons by just looking at these, and so we could make an argument that this could be a responsible way to go through and start correcting for the test that we're making. Okay, so summary, what we're going to do is we're going to assume that based on previous analyses or previous study, we've expected that people's willingness to provide friendship to survivors of combat trauma, again as a consequence of stigma, things along those lines, are going to be maybe a little bit lower than the combination of motor vehicle accident, sexual assault, and natural disaster. And so what we're going to do is we're going to calculate within subjects contrasts here. We're going to compare combat versus these other three, create some confidence intervals of effect sizes for each group. So this is us calling our shots. We're going to test these at per comparison error rates. And then for our between subjects contrasts, our exploratory stuff, what we're going to do is we're going to take a look at group differences in willingness to maintain friendship across each vignette. We're going to correct for more tests than we're going to run, but we kind of ran those in our head. And again, what we're going to do, at least in this example, is run specific contrast comparing our negative group times the against the combination of our other two here. Okay, so first thing we're going to do is we're going to go through. We're going to split file by class, and then we're going to run what's essentially going to be a one-way ANOVA looking at differences in the pattern of means across repeated measures of responsive vignettes for motor vehicle accident, combat, sexual assault, and disaster within each class, right? So we split by class, and then we run our one-way ANOVA. Basically what this is going to do is it's going to give us a specific one-way ANOVA model for each individual class that we've got, right? So this is going to get testing this, and this, and this across groups. Okay, and so what we're going to do, and remember that our variability across our repeated measures in terms of our Fmax wasn't too bad. We obviously going to have the same sample size across all of those, and so we're relatively comfortable within the context of these these simple, might call them simple one-way repeated measure ANOVA, using our information here to start running our within subjects contrast. Now, hopefully you can see this, but essentially what we're going to do for our negative group, we obviously have a clear within subjects effect here, but what we're going to do is we're going to start to go through and calculate our contrast by hand. So if you can see up here in our negative group, we've got three, we're comparing three vignettes, MVA, assault, and disaster against our combat folks. And so what we're going to do is we're going to take calculate the value of our contrast, and I've just kind of done a shortcut here. We've got 1/3, 1/3, and 1/3 for our weights for our non-combat vignettes minus our weight for our combat vignette is going to be -1. So we've got -1/3, or excuse me, 1/3, 1/3, 1/3, -1 gives us a linear contrast forming a standard set. If we go through and run this out, we get a value of our contrast of 0.69 to calculate our test statistic. We take our value of our contrast over, and again, you can find this formula within our lecture slides. We're going to take that over the top of the square root of the value of our contrast squared plus value of our contrast squared plus value of our contrast squared, or excuse me, our weight squared, weight squared, weight squared, plus our weight squared, plus, or excuse me, multiplied by our standard error from our simple effects repeated measures ANOVA table divided by the number of people in each cell. So one thing here, when we're thinking about what error term to pull, some considerations here. I'm going to pull the mean squared error from our greenhouse geyser corrected statistic, right? And so we've got our mean squared error here of 1.634. So we take our the sum of our squared weights multiplied by our standard error over our sample size, take the square root of that, and that's going to give us a test statistic of 3.10. if we take a look at our test statistic of 3.10, and you want to calculate a p-value, again, I'm going to go through and use the degrees of freedom for the actual test and the actual error term that we pulled. So I'm going to say 73. So we say 3.10 with 73 degrees of freedom. Oops. 3.10, 73 degrees of freedom. There we go. So p-value 0.003. Okay. And so if we go through and we run that, and again, this is just a within subjects contrast. Should be fairly familiar with this by now. But again, what we did for this example is use the greenhouse geyser error term here, along with corresponding degrees of freedom. Now, we could also go through and calculate a confidence interval around this contrast. And here, what we've got is we've got a value of our contrast plus or minus our standard error term. Now, standard error term is going to be what we get out of this denominator. If we go through and run the square root of all of this, we get a value of about 0.223. And then what we need to do is set it against a critical value. Okay. Now, for the calculation of our confidence interval, if we're calculating 95% confidence interval using the information that we have here from our test statistic, what I'm going to do is I'm going to calculate a critical t-value using degrees of freedom here. And so again, for the purposes of calculating this interval, what I want to do is I want to say, all right, with 73 degrees of freedom, I believe that's correct. Yeah. With 73 degrees of freedom, you're going to calculate a critical T of 1.993. So 1.993, okay? And if we run that out, we're going to get a confidence interval running from a lower limit of 0.25, upper limit of 1.13. So we're saying that we are expecting a difference. Our point estimate is a difference of about 0.7 of a point reduction in terms of among people with negative beliefs about trauma, in terms of their willingness to maintain friendship with someone who is a survivor of combat, versus average willingness to maintain friendship of people involved in MBA, sexual assault, or disaster. Our population estimates for this point estimate, lower bound of about 1/4 of a point upwards to about 1.1/10 point, 1.13. So again, this is our confidence interval that we've calculated around our value of our contrast here. And then what we can also do is we can go through and calculate an effect size. Here, we're taking the value of our contrast because we've got standard set. So we can just take that. This is literally the mean difference between the average of the 3 other vignettes and our combat folks. So we take that in the numerator. And then for the choice of our standardizer, here we're using all 4 comparisons. We could use a pooled variance estimate, but again, we may have some concerns. Here, what I ended up doing is just pulling the same mean squared error term that we had used for all of our tests, just to make sure things are even Steven. This is a substantially larger variance estimate than our uncorrected test statistics, so we can think about this as being a relatively conservative estimate of effect. But if we pull our error term, our corrected error term from our ANOVA table and use that as our standardizer for our effect size, we get an effect size of 0.54. So in general, based on this, we're saying that reasonable to expect about a half a standard deviation reduction in willingness to provide support to combat survivors as opposed to the combination of sexual assault, motor vehicle accident, and disaster. Okay, so this is all analyses that we're running. So we do see, go back up, we're seeing that this, and maybe we're not surprised, that we're seeing reliably lower ratings for the combat vignette relative to the combination of the other three. We're seeing an effect size of about 0.5 and an average, a mean reduction in the population of somewhere between 0.25 and 1 point, a little over 1 point, in terms of overall reductions in willingness to provide support. Okay, so that's would be sort of our set of analyses that we'd run for negative class, and then we would just go through and do the same thing for our our, get these backwards? No, our benevolent class. And again, this is just the same procedure we did up here. So we calculate the value of our contrast. Weights are all the same. Procedure is the same. Here we get a test statistic of 3.36 associated with p-value 0.001. Confidence interval, again, we're pulling our standard error estimate using the same standard error we used in the calculation of our contrast. Test statistic here, or critical value, based on a critical T with 208 degrees of freedom. We go through and calculate a confidence interval around the value of our contrast here, ranging from lower limit of 0.1 to upper limit of 0.39. Now you notice that our mean squared error relative to what we had up here is much, much lower, right? Here our mean squared, corrected mean squared error was 1.63. Here it's 0.38. And so again, reflecting less variability within this benevolent class as opposed to the negative class. So something to think about. So even though value of our contrast was much smaller, we're still getting a test statistic that's larger in terms of absolute value than what we got up here, based on we're just working with a smaller error term. Much less variability across repeated assessments in terms of where people were at within these groups. So we've got our value of our contrast, our test for our contrast, which is statistically reliable. We've got our confidence interval around our point estimate here, and then we calculate we can calculate a metric of effect. Same procedures we use up here, taking the value of our contrast divided by the square root of our corrected error term here, gives us a test statistic of about 0.4. So for our benevolent group, which is going to be our green line, still seeing reliable reductions in willingness to provide friendship to hypothetical survivors combat relative to our other groups, and we're seeing about 0.4 of a standard deviation reduction in that, with absolute change or absolute difference ranging somewhere from about 1/10 to 0.4 of a point. So much smaller effects, but capitalizing on less variability within that group. Then the same thing for our interpersonal group, contrast set up the same way, even less of a difference, but still getting a test statistic here that's reliable. So test of our contrast is statistically significant, suggesting that we do have evidence for reliable decrease among people in the interpersonal class and their willingness to provide friendship to hypothetical survivor of combat relative to the combination of motor vehicle accident, sexual assault, and disaster. Again, confidence interval that we're calculating here, take the value of our contrast, plus and minus our standard error. That's just sort of, if we sort of calculate this out, you'll get 0.08 or 0.068, and then calculating our critical T for a 95% confidence interval based on our corrected test statistic or corrected degrees of freedom here. So looking at critical value for 226 degrees of freedom, getting confidence intervals around a point estimate of 0.05 to 0.31, calculating our effect size, again value of our contrast over the square root of our corrected mean squared error here, gives us an effect size of 0.33. Okay, so overall, based on our graph, looks like within each group, it doesn't matter whether we're talking about our negative group, our benevolent, or our interpersonal groups, looking like we're getting evidence of systematic reductions in people's willingness to provide continued support, continued friendship for hypothetical survivors of trauma, or of combat, relative to survivors of motor vehicle trauma, sexual assault, or natural disaster. However, we're seeing that based on our effect sizes here and on our graph visually, these data would suggest that an interpretation could be that our negative and benevolent groups fairly similar in terms of their response to these hypothetical vignettes, whereas when we're seeing a more pronounced difference in people's willingness to provide continued friendship in response to this vignette among our negative group relative to sort of these other groups. So again, starting to sort of tease apart and sort of give us a sense for where class may be moderating the pattern of effects across our repeated measure. Okay, and so we're saying that we had some reason to suspect this pattern prior, and so we calculated all of these at per comparison error rates. But what we're going to do now is we're going to go through and we're going to take a look at and run a similar contrasting our benevolent and our interpersonal groups against our negative group, and look for differences at each level of our repeated measure. Okay, this we're going to call exploratory, and if you remember, we're going to test our individual contrast against a critical T of 2.77. Again, it's quite conservative in some ways, sort of differences in opinion on how you might want to go about this, but for the purposes of this example, we'll go through and use this approach. So going down through, we've gone through, ran our simple effects repeated measures, right? So again, we separated or split the file by class, and then just run a one-way ANOVA, and it gave us or one-way ANOVA for our negative, for our interpersonal, and for our negative, our benevolent, and our interpersonal. But now what we're going to do is we're going to split that file off, and what we're going to do is we're just going to run a one-way ANOVA for ratings in response to our MVA, combat, sexual assault, and disaster. So we're basically just running one-way ANOVAs across each one of these, across each level of our repeated measure by class. Again, drawbacks to this is we're losing considerable power, and we're not sort of capitalizing fully on our overall omnibus design, that 3x4 mixed design. But the problem is, and Howell talks about this, is really questionable on whether or not we can start pulling error terms from that overall omnibus ANOVA table, just given our differences in class size or in our cell sizes, violations of homogeneity of variance. Our distributions are kind of ugly. It's too much for me to be comfortable just pulling our mean squared error term out of that repeated measures ANOVA stuff. So what we're going to do is we're going to just run through and run simple effects ANOVAs one ways for our friendship, or our MVA, combat, assault, and disaster, and see if we can find differences across groups here. Okay. So if we go through and run this one-way ANOVA, what we're getting is, so here's our descriptives for a cross group for each one of these vignettes. And then we go down through, we take a look at our homogeneity of variance, and we knew this was going to be the case, right? We already saw this in the overall mixed ANOVA design, that we do have at each, for each vignette, evidence of differences in variability of responses across class for our MVA vignette, for our combat vignette, for our sexual assault vignette, and our disaster vignette. And so when we're thinking about this, what we're probably going to want to do is start thinking about some sort of correction for violations of homogeneity of variance. Okay, so if we go through and we run our one-way ANOVA design, and we go through and we take a look, we see in our uncorrected ANOVA, the only vignette that it's looking like we have evidence of reliable differences across our classes is just for our combat vignette. So again, if we're looking at our graph, looks like our one-way ANOVA here isn't producing anything that's looking promising. Nothing here that's looking promising. Nothing here that's looking promising. Now we did violate our homogeneity of variance test, and I didn't do it in your handout, but we should be doing, in addition to requesting our contrast, is going through and requesting our Welch's test. If we go through and run Welch's on that, get the same pattern of effects as with our each one of our one-way ANOVA models here. P-value, except Welch's turns out to be more conservative here. For Friendship MVA, we get a Welch's P of 0.441. Here it's 0.024. Here 0.222. Here 0.168. And so didn't do it here. Should have done it, but request a Welch's test given anticipated violations of homogeneity variance. So within this, looks like the only thing that we're, at least based on our preliminary omnibus tests, we can start ruling out trying to tease things apart here, here, and here. What we're going to focus on is just our contrast that we requested, comparing our negative group against the combination of our interpersonal and benevolent group, specifically for our combat vignette. So if we go down through and go through and take a look, and again in your write-ups, if you can run contrasts in SPSS, do it, particularly here because this is giving you something that's going to be helpful. We go through and take a look and make sure that we've set up our contrast the way that we want. We are comparing our negative group against our benevolent and our interpersonal group, right? So we've got 0.5, a weight of 0.5, weight of 0.5, a weight of -1 for our negative group. And then if we go down through and we take a look here, we're going to ignore these. Now these didn't turn out, well, actually depending on how you wanted to look at it, but our overall ANOVA ruled those out. So we're not going to look at those, even though it looks like things might be trending here. And we're just going to focus on our combat group. Okay. Now the nice thing about running these contrasts within SPSS, and it'll save you time, knowing that we have a violation of homogeneity of variance, what SPSS is going to do is it's going to run correction for our between subject contrast, correcting for unequal variances. And so again, our preliminary ANOVAs suggest that we're only going to be looking at our combat vignette. And so if we go down through, we're going to go down, let's say, we're going to not assume that we have equal variances here. Value of our contrast is 0.75. So literally the mean the difference in the average of our negative group versus the combination of our benevolent and interpersonal group for this combat vignette is about 3/4 of a point. We've got our standard error. We take our contrast divided by our standard error. We get our t-test running on a corrected degrees of freedom, and we've got our p-value of 0.008, which we're normally excited about, right? We say, oh, this is great. But remember that we implemented a pretty strong correction for running multiple comparisons. And here we're comparing our contrasts within this against a test statistic of 2.77. If we go through and take a look, our test statistic is 2.77. So it's right there on our critical value. We'll go through it and call this sort of close enough, good enough for government work here. And so we'll say that we will call this a reliable effect, specifically for differences between our groups here in terms of our participants' response to willingness to provide friendship to this hypothetical survivor of trauma. Okay. Now, if we're going down through and we're taking a look, we see something that we might be tempted to tease out here, right? We're seeing significant, or what, at least at a per comparison error rate, might be deemed significant. But remember, for each one of these, we violated our homogeneity variance, and so really should be looking at this equal variance not assumed here. And with our correction, sort of what we're going to tease out of this is conclude evidence for reliable differences in our negative group relative to our interpersonal and benevolent group with respect to willingness to provide friendship with hypothetical survivor of combat, suggesting that individuals in this negative group are reporting systematically lower willingness to provide support relative to the combination of the other two. Now what we can do, whoops, I'll set that back up. So again, what we might want to do is, so our point estimate for the difference in our groups is 0.75, but what we might be interested in doing is creating a confidence interval around that, and so we can do that by taking a point estimate of, or excuse me, a value of our contrast here. Where'd my cursor go? Plus or minus my standard error. That's easy. I can just pull that right out of my SPSS table here, and then multiply that by critical T value. Here I'm going to look at a critical T for 49 degrees of freedom. Go through the critical T, 49 degrees of freedom for a 95% confidence interval, 2.010, run that out, and we get upper and lower limits of expected values in the population, looking at the difference in our negative versus the combination of our interpersonal and benevolent group, ranging anywhere from about 0.2 of a point on this 0 to 8 scale, anywhere up to a little over, so about 1 3/4 of a point in terms of values we would expect within the population based on the data that we have available. Okay. Last thing we might want to do is calculate a confidence, or excuse me, an effect size. So what we've got here is we're comparing all three of our groups, and so we really don't have a control group and really don't have a baseline, and this is a between subjects contrast, so we're not looking at the standard deviation of different scores. So really probably our best bet here is some pooled variance estimate across for friendship ratings across each one of our groups. Now remember that we have different sample sizes, and so this pooled variance estimate is going to be important. So what we're going to do is we're going to, if you recall our pooled variance estimate, we're going to take our, here we go, take our negative group, degrees of freedom here, 44 minus 1, multiply this by remember, this is our variance. We're calculating a pooled variance to then get a pooled standard deviation, but I have to start with our variance first, right? So 1.73 squared is 2.993. So we've got sample size minus 1 times our variance plus sample size minus 1 times our variance, sample size minus 1 multiplied by our variance, all over our total degrees of freedom, 43, 84, 93, gives us a pooled variance estimate of 1.351. Okay, and so this is how we would go through and pool our variance estimate, right? And this is if we were maybe only comparing two of these, we could use the same formula. We would just exclude one of those groups. But while this is important, I wanted to show you this from a didactic standpoint. Also note that our pooled variance that we calculated here by hand is also equal to the our mean squared error for combat. Remember that within our ANOVA design, our within groups error within a one-way ANOVA is just going to be the pooled our pooled variance across all of our groups. So you can do this, know how to do this, but your shortcut here within this context is going to give you the same exact value here for your within subject, or excuse me, your within groups error within your one-way ANOVA here. So, but we've got our variance, our pooled variance estimate, take the square root of that, we get our pooled standard deviation, take the value of our contrast, divided by our pooled standard deviation here, and get an effect size of 0.65, suggesting that we've got little over 6/10 of a standard, or about over 6/10 of a standard deviation difference in terms of, or over 6/10 of a standard deviation reduction in reported willingness to provide a continued friendship for a survivor of this hypothetical vignette among individuals within our negative group as compared to the combination of our benevolent and interpersonal group. Okay, and so that takes us through our tests that at least we've set up in our plan here. So at the end of the day, what we can say is we do have evidence. So we've got a main effect of vignette on our repeated measures, and we've got a main effect of our of between groups collapsing across groups, seeing that basically what we would expect is our our negative group to be scoring systematically lower willingness to provide support relative to the other two groups, but both of those main effects actually being conditional effects within the presence of this between by within interaction. Based on our simple effects that we've run, we might qualify this interaction by saying that on average, across participants, irrespective of belief class, we're seeing that people are systematically reporting less willingness to maintain a friendship with a hypothetical survivor of combat trauma relative to the combination of motor vehicle accident, sexual assault, and natural disaster, with the caveat that these difference in the reduction in combat, or excuse me, the reduction in willingness to provide friendship for the combat survivor looks to be more pronounced in people who are reporting these overall negative beliefs about survivors of trauma. Also seeing that within then sort of that being backed up by between subjects contrast here, indicating that we do see evidence of reliably lower ratings of lower friendship ratings among our negative group relative to the combination of our benevolent and interpersonal group here. And so that's the type of thing that we would write up, saying that yes, it looks like our class does have an impact on sort of willingness to maintain friendship with survivors of trauma, but looks like with the real action that's going on here within even the across all groups is less willingness to sort of singling out survivors of combat and being more in general hesitant to provide support to these individuals, likely based on stigma and things along those lines. So these are the types of things we want to touch base on and write up or talk about in your write up. So again, let me know if you have questions on this. And again, remember not to, if you can run something in SPSS, go ahead and run it in SPSS. Unless I tell you you need to calculate it by hand, and you can run it in SPSS, assume that you can do that, because again, you can run the correction for unequal variances, but it's just going to be a real pain. Just do it in SPSS. It's going to be easier. Okay. Hope this helps. Hope this gives you another taste of how to go through and start to tease things apart. But again, come let me know if you have any problems with this. All right. Thanks, everyone.